Alright, what's going on, everybody? It's Professor Hustlenomics with you guys tonight. And we're going to be finding the velocity, acceleration, and speed of a particle with the given position function. So a couple things to note down before we get started. It's going to be that velocity is the first derivative, and acceleration is the second derivative. So with that in mind, let's denote that our position vector is the following, denoted by r of t equals x of t plus y of t. And our velocity vector is v of t equals the derivative of our position vector, which is equal to x prime of ti plus y prime of tj. And our acceleration vector is a of t, which is the second derivative, denoted by r double prime of t, which is equal to x double prime of ti plus y double prime of tj, where I and j are vectors in a two-dimensional coordinate system, and our speed is going to be equal to the magnitude of our velocity vector, which is equal to the magnitude of x prime of t squared plus y prime of t squared. For those of you that don't know, y is a function of f of x. So when you take the derivative, which is dy over dx, which just means differentiate y with respect to x, it's the same thing as saying y prime, which is the same thing as saying f prime of x. So taking the second derivative, which is d2y over dx2, is just y double prime, which is equal to f double prime of x. They all mean the same thing. Derivative, 1 slash. Second derivative, 2 slashes. Okay. And so our example begins with the position function, which is r of t equals e to the t cosine of ti plus sine of tj plus tk. So we begin with finding the velocity vector, which is the first derivative. So we denote our velocity vector by taking the first derivative of the position vector, which is r prime of t, which is going to equal, so if we distribute this back in, we would just get e to the t times cosine of t plus e to the t times sine of t. So using the product rule, we have e to the t times the derivative of cosine, which is negative sine t, plus the second function plus cosine of t times the derivative of e to the t. And that would be for our unit. That would be for our vector I. Plus, we do this. We apply the same product rule to the j vector. So we do e to the t times the derivative of sine of t plus derivative of sine is cosine of t plus the second function times the derivative of the first function. Sine of t times the derivative of e to the t. The derivative in dx, wait, the derivative of e to the t is just equal to e to the t. It doesn't change because it's an exponential function. And so now we have our j vector. And so we follow the same rule for our k vector, which gives us e to the t times t. The derivative of any variable is 1 plus t times the derivative of e to the t, which is just e to the t. And so we have, factoring out our e to the t, we have negative sine of t plus cosine of t plus, again, factoring out our e to the t, we have e to the t times cosine of t plus sine of t. Following the same thing for our last vector, we factor out e to the t, then we have e to the t times 1 plus t. Okay, where I, j, and k are our vectors on the three-dimensional coordinate system, where that's I, my bad, that's I, that's j, and that's k. You can think of I as going in the x direction, and j of going in the y direction, and k of going in the z direction. So now we have found our velocity vector. And so we follow with our acceleration vector, which is the second derivative, denoted by a of t equals r double prime of t. So we have a of t equals double prime of t, which is equal to the first function times the derivative of the second function. So if we differentiate negative sine of t, negative cosine of t, plus the derivative of cosine is negative sine, so we have negative sine of t, plus the second function, negative sine of t plus cosine of t is the second function times the derivative of the first function, which is just e to the t, with our vector I in the x direction. Following the same rule for our vector j, we have the first function times the derivative of the second function. The derivative of cosine is negative sine of t, plus the derivative of sine is cosine of t. Following the product rule, we do the second function cosine of t plus sine of t times the derivative of the first function, which is just e to the t. And that is our j vector in the y direction. Following our k vector, which would be in the c direction, we would have e to the t, which is the first function, times the derivative of the second function, which is 1 plus t. The derivative of a constant is 0. The derivative of a variable is 1. Plus the second function times the derivative of the first function. The derivative of e to the t is e to the t. Following our product rule, making it look pretty, we have e to the t. We factor out an e to the t. And so we have, we factor out an e to the t, and we have negative cosine of t minus sine of t plus negative sine of t plus cosine of t. Following our prettiness, we factor out an e to the t, and we have negative sine of t plus cosine of t plus cosine of t plus sine of t for our j vector in the y direction, and our I vector, which is in the x direction, plus e to the t. We factor out an e to the t. 0 plus 1 is 1, so we have a 1 there. And we'll get back the same thing, plus 1 plus t. Because if you notice, our parentheses indicate that when we distribute back e to the t into this this quantity, we'll get the same quantity here, and when we distribute it back into this quantity, we'll get the same quantity here, and it follows with the next vectors. And so, continuing to simplify, we have e to the t, negative cosine of t plus cosine of t cancel out. Negative sine of t plus a negative sine of t, we have a negative 2 sine of t. For our I vector, which is in the x direction. For our j vector, we have e to the t times negative sine of t plus sine of t, they cancel out. Cosine of t plus cosine of t, that gives you 2 cosine of t. Plus e to the t which we have right here, is 1 plus, there's nothing being multiplied right there. If there was a 2, then you wouldn't be able to do 1 plus t, which gives you 2 plus t. That means that you would have to distribute the 2 first. But since that is not the case, we can just do 1 plus 1 is 2 plus t. K. For the k vector, which is in the z direction. And we have now found our acceleration vector. And so we follow to find our speed vector. And so following the formula for our speed vector, which is the magnitude of the velocity vector, the velocity vector is this one. Oh, whoops. Let me see if I can get a better look at that. And so following our formula, our speed formula, we have the magnitude of v can be the square root of x, which is this side right here, because it's a vector I and it has to do with the x axis, which we're going in the x direction. So we're going to go ahead and grab our I vector, e to the t, negative sine of t, plus cosine of t squared. Whoops. Squared. Plus our y of t, which is in the y direction, so it would be our j vector, which is e to the t times cosine of t plus sine of t squared. Now, this formula is for a two-dimensional coordinate system, and because we have an I, j, and k, we have a three-dimensional vector. So the same rule applies for 3 dimensions. So we just add our z vector, which is the k vector in the z direction. I'm sorry, our k vector, which is in the z direction. We have e to the t times 1 plus t squared. And so distributing, we have e to the 2t times negative, wait, that would not be a negative. Using the formula of a squared plus 2ab plus b squared, we have sine squared of t, because remember the exponent of 2 applies to e to the t, and it applies to this quantity right here, because e to the t is being multiplied with this quantity right here, then the exponent applies to both. So then we have sine to the t plus 2 times sine times cosine plus 2 sine of t cosine of t be minus plus cosine squared of t plus, same thing right here, because there's a quantity right here that's being multiplied with e to the t. The exponent applies to both. So we'd have e to the 2t times cosine squared of t plus 2 times a times b, 2 cosine of t sine of t plus sine squared of t plus e to the 2t times 1 plus 2 times a times b, which is 2t plus t squared. And so if you take a look, we have something in common in all of these quantities. And so the best thing I can recommend you to do, my friend, is to factor out an e to the 2t, leaving us with, so you can understand, leaving us with sine squared of t minus 2 sine of t cosine of t plus cosine squared of t plus cosine squared of t plus 2 cosine of t sine of t plus sine squared of t plus 1 plus 2t plus t squared. And so some of the things that are going to cancel out here are going to be, if you recall, we have a times b under the square root is the same thing as the square root of a times the square root of b. So following that rule, we can separate e to the 2t, and we can separate this whole quantity right here. And e to the 2t is the same thing as saying e to the t squared, because when you have an exponent raised with an exponent, you multiply those exponents. So we have that times, let me make this a little prettier, times sine squared of t, sine squared of t minus 2 sine of t, which all in all gives us negative 2 sine of t plus 2 sine of t. They cancel out. We have cosine squared of t plus cosine squared of t, sine squared of t plus sine squared of t. So we have 2 sine squared of t plus 2 cosine squared of t plus 1 plus 2t plus t squared. And so our square root is going to cancel out with our exponent, and we're just going to be left with e to the t. And so we can factor out a 2 from this. we can factor out a 2 right here, and we'll have sine squared of t plus cosine squared of t plus 1 plus 2t plus t squared. Now, for those of you that didn't take trigonometry, there's an identity called the Pythagorean identity, where sine squared of t plus cosine squared of t is equal to 1. And so with that being said, and with that being in mind, we have 2 times 1 plus 1 plus 2t plus t squared, which gives us 2 plus 1, 3, plus 2t plus t squared. And so our speed, which is the magnitude of the velocity vector, is equal to e to the t in descending order times the square root of 3 plus 2t plus t squared, and our velocity vector, which is v of t, which is equal to the first derivative of the position vector. I believe it is this whole thing right here. And our acceleration vector, which is a of t, denoted by the second derivative of the position vector, is going to be everything right here. Where this is our x, our y, and our c. So where this vector is in the I direction, and where this vector is in the j direction, and where this vector, our k vector, is in the k direction, where the same rule applies for all what's it called? For all vectors in our 3D plane. Professor Ozonomics, thank you.